Good afternoon.
Good afternoon, teacher.
Did I show you the vector method of resolving physics? Amina, did I show you the vector method? Because in mathematics I have. I don't remember doing so in physics. If this is 3 newtons, 1 newton, 4 newtons, 8 newtons. This has 40. This one has 30. Where are the rest? So we can find the resultant force from the sum of force 1 plus force 2 plus force 3 plus force 4 in vector form. When you look at force 1 can be the 3. You resolve the 3 to the horizontal, you have 3 cos of 30. When you take the 3 to the vertical, you have 3 sine of 30. When you bring the 8 to the horizontal, you have 8 sine 40. When you take the 8 to the vertical, you have 8 cos 40. But the 8 cos 40 is negative because it's going in the negative y. Whereas these ones are positive. Then the 4 is also going to be negative as it goes in the negative x. Therefore, F1 can be 3 cos of 30. Vertical component is 3 sine of 30. Ideally, it means x1 and y1. The value in the x-axis and the value in the y-axis. When I come to the second force, I can have force F2. It has a component in the vertical, but no component in the horizontal. So F2 is 1, 0, 1, this one. When you come to 8, which is force 3, it has 8 sine 40, negative 8 cos 40. And lastly, we have force F3, F4. F4 is going to be negative 4, 0. When I identify the vectors, I'll now have force F resultant going to be 3 cos 30, this sine 30. plus 0, 1 plus negative 4, 0 plus 8 sine 40 negative 8 cos 40. So we get a calculator and add the first ones together. This sine plus 1 can you press your calculator and add all this together? So add the first one. What do you get?
$3.7404. $3.7404. Negative 3.6284.
That is the resultant force in vector form. This represents the x, this represents the y component. So we sketch the x in the positive direction, the y in the negative direction. Therefore, this is the same as having it in this form. Sum of forces in x, sum of forces in y. So sum of forces in x is 3.7404, in y 3.6284. One may wonder, why are we missing the negative? We are missing the negative because the arrow, this arrow here is showing us that you have to go down in the y. So the arrow is represented by the negative in the diagram. So the magnitude can be found as the square root 3.7404 squared plus 3.6284 squared. What answer do we get?
$0.825.
Hmm?
0.825.
It is impossible. When these ones are threes, you can't have 0. 5.211. So you can write the answer to 2 decimal places. Now we also need to get the direction. That is tan theta is equal to 3.6284 divided by 3.7404. What is theta? Theta is tan arc of 3.6284 out of 3.7404. What answer do we get? (44.13 degrees) below the positive x-axis. You know, this was the positive x-axis, this one. So even this one will assume to be the x-axis. So that's why we are saying below the positive x-axis. Any question on this one? Because you're going to try out one before I can finalize this topic. Screenshot that very fast and try out this one. You have 5 minutes to do this one. Whichever method you use, I have no problem. So try that one out very fast.
Teacher, the angle on 3 newtons, is it 50 degrees or 30 degrees?
The 3 Newton, it is 30. So you resolve horizontally and vertically. So you're finding the magnitude and resultant force. Find the magnitude and direction of the resultant force of those forces. This is the diagram I'd moved off. Let me redraw. We have approximately 2 minutes. You're going to share your work on WhatsApp. I check it out. Yes, answers? No one has submitted yet. Okay, someone has submitted. Check it out. Okay, someone already has an answer. The sum of forces in the horizontal is correct. Yeah, it's what? 5 point. This is 3, this is 7, this is 4, this is 5. Oh, this is 8. Eh? Did I give this as 8? Guys, did I give this upper 5? Eh? If it is 5, then this is wrong. The same as this one. This person, please try again as we wait for the rest. You must have missed out some value. Let me see. 5 cos. He used this angle as 20. That angle was 30. Isn't it? Hey, it was 20. Yeah, it's okay. It was 20. Then this one was 7. Then this one was 4. And this one was 3. Five cos 20, 4 sine 60 minus 3 cos 30. Yes, this statement is correct. Negative 7 plus 5 sine 20 plus 5. Hey, you are using 5 here. This is wrong. This is 3. That is where your problem is. So please sort yourself. Let me see another person. Any other person who has sent? No one.
But teacher, the 5 Newton force is on the 20 degrees.
Let me check again. Then the statement is correct. The statement was correct, that first statement. Then the statement of 5 sine 20 minus 4 cos 60 minus 3 sine of 30. And no, this person is using this angle as 30. Did I give that angle as 30 or 50?
Teacher, I asked you if the angle was 30 degrees or 50 degrees on the 3 Newton force, and you said that.
Okay. There it become right. But only you. The others, I expect them to use 50. And the others are very quiet. I don't know why they're not saying a thing. Are they sending work? I hear some work coming through. Let me see. No. Please send us work. So if the rest are not submitting, then we have to introduce what we have to go for next. Amina is confused. Yes, Amina, where is the problem? Amina, please talk to me.
Teacher, I'm not able to identify the angles.
Do you see this? Can't you see this is 60? This is 20. This is 50. Can you see those angles?
Yes.
When we compress an angle, what do we use?
Cos.
Can we compress 5? Compress 20? What shall we have in the horizontal?
5 cos 20.
5 cos 20. When you move away from the angle, we use what?
Sine.
Move away from the angle. As you move away with the 5, what do you have?
5 sine 20.
5 sine 20. Correct. Now, you have the 4 here. You see the 4? It's the 60 up here. Sometimes some people want to compress always to the horizontal. You always want to compress the horizontal and we maintain that?
Yes.
Then put this angle as what? 30. Because the whole of this is what? 90. Okay? Now compress 30 using 4. What shall you have?
Teacher, that's where I got confused.
And now if you have put, have you understood how I've got the 30?
Yes.
Then compress 4, you get 4 cos what? 30. Okay? Then when you take the 4 to the vertical, you are moving away from the 30. You will have 4 sine of what? 30.
What about the 60? You stop using it.
I asked you, do you want to use the angle about the horizontal or you wanted to use the vertical? You told me you want the horizontal. So I made the 60 be analyzed as per the horizontal. So I got the balance of 30 here.
Okay, I have been using both.
Hey, you have been using both 60 and 30.
Yes.
Okay, you always pick one, eh? Okay. So in case you had decided to remain with the 60, it would have been 4 sine 60 because you'd have been moving away from the 60 going that way. Whereas if you are going to the vertical, you would compress the 60 to be 4 cos of 60. So these are the same. Okay. Those of mathematics know from trigonometry, that is the same. Even you in submath, when you cover submath, you'll find out that they are the same. Now, when you compress the 30 to the horizontal, you get it facing this way, and you get 3 cos 30. Then to the vertical, it will become 3 sine 50. This is 50, not 30. Then you start summing up together. Okay?
Okay.
So please finish it up and we'll see what answer you come up with. Teacher, when you know the negative, that it is a negative when it comes up to summing. Now, me, I always want to show the negative from this very stage. Eh? Okay? I'm of the view, you let the negatives be attached right here. That this is negative. This is negative. The 7 is negative. The 40, the 4 sign is negative. So that when you write down, for example, sum of forces in Y, you know that this is positive. You'll have 5 sine 20 minus 7 minus 3 sine of 50 minus 4 sine of 30. Then when it comes to summing up forces in X, you would have 5 cos of 20 plus 4 cos of 30 minus 3 cos of 50. If you write in vector form, you would have the resultant force is equal to 5 cos 20, 5 sin 20, plus 0 negative 7, plus 4 cos of 30, and negative 4 sin of 30. Then plus negative 3 cos of 50, negative 4 sin of 30. Then you add. So that's how you can go about it to know which one is negative and how to present them. I think, Cynthia, you've got that. You need any other explanation better than that? So the new definition I want to talk about before we close is what we call crossing a river. I think all of you have ever seen rivers. And the river has a downstream and an upstream. And the river flows downstream. In Uganda, they say what you call north in Uganda is called Maserengeta. So northern Uganda is, in Uganda, it's called Maserengeta ga Uganda. Reason being, all rivers are heading to the north. So the Baganda used to say the rivers are flowing downstream towards the northern direction. Then the southern direction, they call it upstream. So when crossing a river, one should mind to know if you're to cross a river, you need to take into account where does the river come from and where does it head. And as it moves, there are certain conditions or cases which you can use to cross the river. So the cases are going to be defined as we have definitions. We have case 1. Case 1 is called crossing a river by shortest route. Crossing a river by shortest route. Sometimes we call it shortest distance. In this case, we consider a river flowing at a current U, and a swimmer or a man rowing a boat at V meters per second. If the river is S meters wide and the resultant is VR, then this is how we go about that definition. This is then I've missed something here. We set the course upstream for the man or the boat. So therefore, it looks like this. This is our river. We are assuming the current is flowing downstream in that direction. Let's assume the river is of width D. The river is of width D meters. Then we start from a point here. We are supposed to cross directly opposite. That is how we cross by shortest distance from point A to point B. So what we do is set the course upstream to some point C. When you set the course upstream to some point C, what happens? The river will blow the person until he or she arrives where they have to arrive, right here. In that sense, we could have set the course somewhere this way at point C. Then this person or the swimmer or the boat, which is moving at a velocity V, then we have the river that is blowing at a current U, then this becomes the resultant VR. So it means the guy can set the course at an angle theta to the bank. This is called the river bank. Therefore, with this definition, the first one, we can see that if you extract out that right angle triangle, then it looks like this. With this as V, with this as U, with this as VR. Therefore, V squared is equal to U squared plus VR squared. Then the resultant velocity with which the person would cross is going to be V squared minus U squared. So VR is going to be the square root of V squared minus U squared. And this is the first case definition for crossing the river by shortest route. In this instance also, we can be asked to find time for crossing. Time T for the crossing is got from any known distance over the corresponding velocity. So the time can be got from FB out of VR, or from BC out of U, or from SC out of V, which is the same as D out of VR. So if you want to check whether you are right, you check with the time with all those ratios. The time is going to be the same. Also, they can ask you for the angle set to the bank. Cos theta is equal to U out of V. Okay. Sometimes also you can get tan theta is equal to VR out of U. So all those definitions can help us in crossing the river by shortest route. So that is the first definition. If we don't have any questions, you can have the definition down. Any questions? No questions? I introduce the second case. So for case 2, have you taken the screenshot? So I will require you to have these definitions revised because I hope to start examples next week, not today. So I will expect you to have revised them fully by the time I come to show you examples. Case 2. Crossing by quickest time. Sometimes we call this quickest crossing. So for quickest crossing, what happens? We set the course of the boat or the swimmer perpendicular to the bank. To a point directly opposite the starting point. Directly opposite the starting point, and the river current takes him downstream. As shown. So we shall set a course a point directly opposite current will take us downstream. So in this sense, we have set the course to a point here, C, then the river current blows us down to point B. That means this is the velocity of the boat or the swimmer. Then this is the river current U. Then this is the resultant velocity with which one crosses. And the river is of width D. So we have set the course of the boat or the swimmer perpendicular to the bank. Therefore, the resultant velocity will be got from V squared plus U squared. Now, because these are velocities, the resultant will become the square root of U squared plus V squared. So in that sense, having gotten that, we can find the time from any known distance. The time can be got from SC out of the corresponding velocity V, or from BC out of the corresponding velocity U, or from AB out of the corresponding velocity BR. So with this, you will have to realize that the easiest time can be got from the distance D, which is known, the width of the river, out of the velocity with which the boat or the swimmer is crossing. Sometimes they ask you the distance downstream. They ask you for the distance downstream. We can have tan of theta is equal to U over V, which is going to be the same as CB or BC out of SC. So if you know U and you know V and you know SC, SC is already D. So you can get U out of V is equal to CB out of D. Therefore, CB can be attained from U out of V times D. Okay. So we are in this position possible to go ahead and find anything that requires quickest crossing. So for quickest time or quickest crossing, you set the course directly opposite to a point on the other side of the river, then the water current goes on blowing you downstream. The idea is you don't cross up to that point C. You head to C, but the water is pushing you. And according to what you've said, you will land at B. Those of us who have ever been on a ferry, I don't know whether some of you have ever been on a ferry. The ferry uses that principle in crossing rivers. You see they are setting it upstream, but then as it moves, you'll end up seeing it landing on the other opposite side, but slightly downstream from where it came from. So this is the mechanics of crossing a river. In physics, we don't talk so much about them. We can stop there at those two. In mathematics, we talk about many of them. Let me send an example. This one must end by 3:20. Okay, let me do a number. Let me say, I want to send the number to do right now. Okay. Here it is. Number, where are you? Here we are. Okay. There's an example here that I would like us to share. It says a man wishes to cross a river which is 50 meters wide and flowing at 5 meters per second. The man who wishes to row the boat at 8 meters per second in still water, determine the time taken by the man if he is to take the shortest route and the direction of his motion. So we have said for shortest route, the destination is directly opposite. Then what do? We set the course upstream, then the river current blows us downstream until we reach that point which is directly opposite. And in that sense, this is what is going to happen. You start from A, you set the course at C, but then the river blows you up to B. So this becomes your line of the resultant, VR. This becomes your V. This becomes your U. The width of the river, this is 90 because it's a right angle triangle. So the distance between the two rivers, the two banks is 50 meters. Therefore, the first question is asked is determine the time taken by the man. So the time taken by the man will depend on VR, which is going to be got from V squared minus U squared. So VR, the resultant velocity, will be the square root. VR is the velocity at which the man swims, which is crossing 8. The river flows at 5. So it is 8 squared minus 5 squared. What is VR? VR is square root of 64 minus 25. What result do we get for VR?
Teacher, why are you subtracting?
It's because, let me take you back to the definition. It's because if you recall our definition of shortest route, it starts from here with addition. But when you make VR the subject, it induces into subtraction. Okay, from this Pythagoras theorem, you would get VR, you would get V squared is equal to VR squared plus U squared. So when you make VR the subject, you'll get V squared minus U squared. That's where the subtraction comes from. All right?
Yes.
Okay?
Yes, thank you.
Oh, my work has gone off. So we have subtracted, we have got we have seen this is 5, this is 8, VR. Then we have seen that VR can be got from the square root of 64 minus 25. And the answer we have got 6 point what? $6.24. Someone has posted an answer. Now the time, we use this side. The reason why we drew this triangle without finishing, according to this one here, you see the triangle was finishing the entire what? The entire width of the river. Eh? So ideally, the point is that if I look at AB, the whole of AB is corresponding to VR, or it's the velocity acting along that line. So the time can be got from AB out of VR. But AB is the width of the river, which width of the river was 50 meters, divided by the resultant velocity, which is resultant velocity is what? 6.24 meters per second. So this is divided by 6.24. What time do we get in seconds?
Zero, 1, 3.
Let me check it out using other illustrations. What if I use distance SC? This is my C. SC, if I use this right angle triangle, I need to first get this angle. This is theta. This is theta. This is 5. This is 8. Cos of theta is equal to 5 out of 8. What is theta? But before I can even proceed with that, this is the same as CB out of SC. If you get theta, what is theta? Cos inverse of 5 over 8.
$51.32 degrees.
51.32 degrees. So I can use tan theta, and I get, because this is theta, the side AB is known, and I get AB out of CB, which is the same as what? AB is the width of the river, which is 50, out of CB, which I don't know. So CB can be got from 50 out of tan, or 51.3. And we get CB.
$40.0320.
If I've got CB, come here and find SC. SC will be equal to CB out of 5 over 8. So which is 40.32 divided by 5 over 8. What answer do you get for SC?
$64.0513. Sorry.
Now let's check out the time. Can I use SC out of the velocity along SC? Velocity along SC was V. So velocity along SC is SC out of 8, which is 64.05 divided by 8. What answer do we get? 8 what?
8.006.
006, approximately 8 seconds, just like the other one. Then what if I use BC over U? BC is the same as 40.32 divided by 5. Don't you also get 8.00 seconds? I guess we do.
Yes.
So it means you're on the right track. That's why I say time is found using any known distance divided by the corresponding velocity. Okay? So if you have got n of the distances and you know the velocity along that line of that distance, you can always use that and find the time. I'm sending you one number to try out. This one is done and the time is done. So we shall start from there next time. Unless if someone has a question.
You get the 64 and 25 on the
When do what?
where did you get the 64 minus 25?
I got it from the squares. This one. It came from, you know, VR, we say it is the same as what? V squared minus U squared. So V was 8 squared minus 5 squared. So that's how I conclude that VR is the square root of 64 minus 25. Okay. That's how it came about. They were just the squares of 8 and what? The squares of 8 and 5. Okay, if no further questions, allow me send those numbers I've given you. Try them out. Shall start from there next time.